Okay, continuing with Codecademy. Relational operators. Now that we understand Boolean expressions, let's learn how to create them. In Python, we create Boolean expressions using relational and logical operators. Relational operators compare two values and return true or false based on the operands. For this reason, you will sometimes hear them called comparison operators, but we're going to call them relational operators. Okay, they return true or false based on the operands. And then there's logical operators. Logical operators are used to combine multiple Boolean expressions. The two relational operators we'll cover first are equals to and not equals to. The equals to character, or operator, which looks like that, returns true if both its operands are the same. Otherwise it returns false. For example, the Boolean expression A and then the equals operator B will return true if the values A and B are the same. Otherwise it will return false. The not equals to operator is the negation of the equals operator. The Boolean expression A not equal to B will return true if the values A and B are different. Otherwise it will return false. We can create Boolean expressions by comparing two values using these operators as shown below. So 1 equals 1, we can see that here. Well, that will evaluate to true as the operands are the same. 1 not equal to 1. That evaluates to false, as the operands are the same. You see, it's not true that they are not equal, these two operands, because they are equal. So it comes back as false. 2 not equal to 4, well, that's true. It's not. 3 equal to 5, that will evaluate to false, because it's not equal to 5. And then this is 7 equal to the numeric data type 7? No, so that evaluates to false as the operands are different types. This is a string and that is a numeric data type. So instructions: determine if the following Boolean expression is true or false. Assign your answer as true or false in the variable first expression. So have a look at it. Next, consider the following expression. 3 plus 3 is not equal to 3 multiplied by 3. If the above Boolean expression is true, initialize a second variable called second expression to true. Well, 3 plus 3 is 6, and 3 multiplied by 3 is 9, so they're not equal. So that is indeed true, they are not equal. So I'm going to say second expression equals true. Now consider this expression. 3 multiplied by 3 is equal to the string 9. Well, I'm going to say that is false. Third expression, I'm going to use the assignment operator. Notice how here this is the assignment operator. And we have a video walkthrough. If you get stuck during this lesson or would like to see an experienced developer work through the lesson, watch this lesson walkthrough video. Let's take a look.
Exercise number 3, Relational Operators, Part 1. In this exercise, we'll learn about two frequently used relational operators in Python and what they accomplish. Let's first start with defining relational operators. Relational operators are used to compare two items together. They return a true or false value depending on the result. Because of this, they are also known as comparators. Two of the main relational operators are equals and not equals. These use double equal signs and an exclamation point followed by an equal sign. One of the common use cases is not only to compare values, but also to compare data types. Double equals will test if the data types are the same, then if the values are the same. Let's take a look at some examples on the right. First, we have 1 double equals 1, which returns true since the values are the same. Next is 2 is not equal to 4. This returns true since 2 is indeed not equal to 4. Then we have 3 double equals 5. This returns false since they are not equal, so the expression is not true. Finally, we have the string 7 double equals the number 7. This returns false since the data types are not the same. Now let's switch over to the lesson and go over the instructions portion of the exercise. In this exercise, we need to determine if each Boolean expression is true or false. To start, we have the expression 2 times 2 is equal to 2 plus 2. The left side of the relational operator evaluates to 4, and the right side of the relational operator also evaluates to 4. The double equals relational operator returns true if the values on either side are the same, and false if they're not. Since both sides are equal to 4, the final result is true. So let's set first expression equal to true. And hit run. Next, we have the expression 3 plus 3 is not equal to
we've got
3
it. Next. Boolean variables. Boolean variables. Before we go any further, let's talk a little bit about true and false. You may notice that when you type them in the code editor with uppercase T and F, they appear in a different colour than variables or strings. This is because true and false are their own special type, bool. True and false are the only bool types, and any variable that is assigned one of these values is called a Boolean variable. Boolean variables can be created in several ways. The easiest way is to simply assign true or false to a variable. So you could say set to true, use the assignment operator, and then give the value of true with an uppercase T. Same for false. So that's how we create. So now, because the value of this variable is true, it's called a Boolean variable. That's all we mean by the term Boolean variable. You can also set a variable equal to a Boolean expression. So here we have a variable and we've assigned to it 5 not equal to 7. And that whole relational operator with the operands that it operates on is called a Boolean expression. The whole thing is a Boolean expression. Or 1 plus 1 not equal to 2. 3 multiplied by 3 equal to 9. These variables now contain Boolean values, so when you reference them, they will only return the true or false values of the expression they were assigned. So if we print bool 1, we won't actually get 5, it won't print 5 not equal to 7. It will just come back with true. That's really important, I think. If you say print boolean bool 2, it won't print to the console 1 plus 1 is not equal to 2. It will just print false. So these relational operators, not equal to and equal to, have a sort of special relationship to the bool data type. They collapse down into the bool data type. Instructions: create a variable named myBabyBool and set it equal to the string true, with a lowercase t at the beginning. So I'll do that, myBabyBool, and we're going to assign to it the value true, the string true, check the type of my baby bool using the type function. So we can do type, here's this type function, and all we need to feed in is the actual variable. So type my baby bool. But you'll have to print it to get the results to display in the variable. So what I'm now going to do is assign the function to a variable, my baby bool type, and then just print my baby bool type. Okay, so this is interesting. What I've been told is check the type of my baby bool by running print and then just put in the function, in the print function, the type. So I've kind of spread it out over 2 lines, but what I should do, I've kind of created an intermediate variable. I've said do the type, assign it to this intermediate variable, then print the intermediate variable. But what we can do instead is just put the function in a function. So that's the idea I'm missing. So instead I'm going to get rid of that line, but I am still going to use the type function, but it's going to be in here. Print my baby bool, and I don't need this other variable name. Okay, run, class string, okay. It's not a Boolean variable. Boolean values, true and false, always need to be capitalized and do not have quotation marks. Create a variable called myBabyBool2 and set it equal to true. So myBabyBool2 and set it equal to true. And we'll click run. Check the type of myBabyBool2 and make sure you successfully created a Boolean variable. So I can do print type my baby bool2, and hopefully it will print the fact that it is a Boolean. There we go. So it says class bool. Okay, next. The if statement. Okay, Boolean variables, Boolean expressions, blah blah blah. I thought I was learning how to build control flow into my code. You are, I promise you. Understanding Boolean variables and expressions is essential because they're the building blocks of conditional statements. Okay, Boolean variables, Boolean expressions are the building blocks of conditional statements. Recall the waking up example from the beginning of this lesson. The decision-making process of is it raining? If so, bring an umbrella is a conditional statement. Here it is phrased in a different way. If it is raining, then bring an umbrella. Can you pick out the Boolean expression here? Right. It is raining is the Boolean expression, and this conditional statement is checking to see if it is true. So it's either true that it is raining or false that it's raining. So if it is raining equals operator true, then the rest of the conditional statement will be executed and you will bring an umbrella. So this is the form of a conditional statement. If, expression, then bring an umbrella. And in Python it looks very similar. If is raining, colon, print bring an umbrella. You'll notice that instead of then we have a colon. That tells the computer that what's coming next is what should be executed if the condition is met. Let's take a look at another conditional statement. If 2 is equal to 4 take away 2, print apple. Will this code print apple to the terminal? Well, it will, won't it? Yes, because of the condition of the if statement, 2 being equal to 2 take away 2, is true. Let's work through a couple more together. In script.py, so py is just a file extension for a Python file, there is an if statement. I wrote this because my co-worker Dave kept using my computer without permission, and he is a real doofus. Right, if the username is Dave, it tells him to stay off my computer. Enter a username in the field for username and try running the program. So enter a username in the field, so let's put Dave, and let's make it a string. And we can see that then the next lines say if the username does have Dave assigned to it, that's the assignment operator, print get off my computer Dave. Great. File, home/cc user, Codecademy user, workspace, learn Python control, flow control, comma, line 4, if username equals Dave. Syntax error. Invalid syntax. Maybe you meant the equals operator or colon equals instead of equals, the assignment operator. Oh no, we got a syntax error. This happens when we make a small error in the syntax of the conditional statement. Read through the error message carefully and see if you can find the error. Then, fix it and run the code again. Well, it's because we're not assigning when we're in an if statement. We have to use the equals operator. And now it works. Get off my computer, Dave. And of course, if I change it to, say, Helen, we don't get that. Dave got around my security and has been logging onto my computer using our co-worker Angela's username, AngelaCatLady87. Set your username to be Angela_CatLady_87. So AngelaCatLady87. Update the program with a second if statement so it checks for Angela's username as well and prints, I know it is you, Dave, go away. If username equals Angela Cat Lady 87, print I know it is you, Dave, go away. Okay, what's gone wrong? Oh, we need the colon there. Run. Great. So don't forget that colon and remember to use double equals, the equals operator. Okay, next. Let's talk about relational operators again. Now that we've added conditional statements to our toolkit for building control flow, let's explore more ways to create Boolean expressions. So far we know two relational operators, equals and not equals, right? These are called relational operators, the equals operator and the not equals relational operator. But there are a ton more. We've got greater than, and of course the thing which should be bigger if the overall expression is to be correct is on the big wedge side. This has a directionality, this operator. We have greater than or equal to, and again notice how it's arrow then the equal sign. We have less than, and we have less than or equal to. Let's say we're running a movie streaming platform and we want to write a program that checks if our users are over 13 when showing them a PG-13 movie. We could write something like, if age, that's the variable, is less than or equal to 13, so they can't actually be 13 either, they have to be actually 14. So if age is less than or equal to 13, colon, and now we have what we want to do, print, parental control required. Okay. This function will take the user's age and compare it to the number 13. If age is less than or equal to 13, it will print out a message. Let's try some more. Instructions. Create an if statement that checks if x and y are equal. Print the string below, if so. So here's a comment. It says write the first statement here. So I'm going to say if x is equal to y, and I am doing kind of a space between the operand and the operator. So it's not just x, y like that. It's x, bit of space, now the operator, y, print these numbers are the same. Good. The nearby college, Calvin Coolidge's Cool College, or 4C as the locals call it, requires students to earn 120 credits to graduate. Write an if statement that checks if the student has enough credits to graduate. If they do, print the string, you have enough credits to graduate. So they've already written this variable, declared this variable called credits. So I'm going to say if credits equals is greater than or equal to 120, and now the logic, print, or the thing that we'll do, not the logic, the consequent, print you have enough credits to graduate. I think that's right. Can a student with 120 credits graduate from Calvin Coolidge's Cool College? Yes. And concept review. Want to quickly review some of the concepts you've been learning? Take a look at this material's cheat sheet. And community support. Still have questions? Get help from the Code Academy community. Boolean operators and. Often the conditions you want to check in your conditional statement will require more than one Boolean expression to cover. In these cases, you can build larger Boolean expressions using Boolean operators. Boolean operators. These operators, also known as logical operators, combine smaller Boolean expressions into larger Boolean expressions. There are 3 Boolean operators that we will cover: and, or, not. Let's start with and. And combines 2 Boolean expressions and evaluates as true if both its components are true but false otherwise. Consider the example. Oranges are a fruit and carrots are a vegetable. This Boolean expression, that's a Boolean expression, okay? This Boolean expression is comprised of 2 smaller expressions. Oranges are a fruit and carrots are a vegetable. Okay, so that's one part and that's the other part. Both of which are true. Carrots are a vegetable, oranges are a fruit, and connected by the Boolean operator and. So this is a connector. So the entire expression is true. Let's look at an example of some AND statements in Python. So we might have this in rounded brackets and then AND connected to this in rounded brackets. We might have this expression and this. So 1 is smaller than 9 and 5 is not equal to 6. 1 plus 1 is equal to 2 and 2 is smaller than 1. 0 is equal to 10 and 1 plus 1 is equal to 1. Well, of course that one comes back false. Notice that in the second and third examples, even though part of the expression is true, the entire expression as a whole is false because the other statement is false. Okay, so here 1 plus 1 is equal to 2. Well, that's true. However, this is false, and so that ruins the whole thing. And so overall, we have a false statement. The fourth statement is also false because both components are false. 1 plus 1 is not equal to 1, and 0 is not equal to 10. Instructions. So we have statement 1, statement 2, credits has been assigned a value of 120, GPA has been assigned 3.4. And we have an if statement here. If credits, that variable is greater than or equal to 120, print you meet the requirements to graduate. Set the variables statement 1 and statement 2 equal to the results of the following Boolean expressions. So statement 1, 2 plus 2 plus 2, which is 6, is greater than or equal to 6, so that's true, and minus 1 multiplied by minus 1, which produces a positive number. So when we multiply two negatives, we get 1. We get a positive number, in this case 1. Is 1 smaller than 0? That's false. So overall, that is false. So remember, this, just like Boolean expressions, oh no, these are Boolean expressions. Okay, so Boolean expressions just become Booleans. Okay, it just collapses down into false. Here we have 4 multiplied by 2, which is 8. Is 8 smaller than or equal to 8? That's true. 7, take away 1, well that's 6. Is 6 equal to 6? Yes, it is. So true and true, so that is true. Run, and now it's got a tick. Let's return to Calvin Coolidge's Cool College. 120 credits aren't the only graduation requirement. You also need to have a GPA of 2.0 or higher. Rewrite the if statement so that it checks to see if a student meets both requirements using an AND statement. If they do, print the string you meet the requirements to graduate. So it's not just if credits are greater than 120, it's if credits are greater than 120 and, so we can just write that, and GPA, which is a variable we've declared, so I'm allowed to do that, and GPA is greater than or equal to 2.0. Now we can print you meet the requirements to graduate. Okay, great. Boolean operators OR. The Boolean operator OR combines two expressions into a larger expression, just like before with AND, that is true if either component is true. Consider the statement, oranges are a fruit, or apples are a vegetable. This statement is composed of two expressions. Oranges are a fruit, which is true, and apples are a vegetable, which is false. Because the two expressions are connected by the OR operator, the entire statement is true. Only one component needs to be true for an OR statement to be true. In English, or implies that if one component is true, then the other component must be false. This is not true in Python. If an OR statement has two true components, it is also true. Let's take a look at a couple of examples in Python. So we've got 4 separate lines here, 1 line, 2 lines, 3 and 4. And each line has the OR operator on it, OR, and OR. True, or 3 plus 4 is equal to 7. Well, overall, that OR statement is true, so it evaluates to true, so we put hashtag true. Because that is obviously true, that is the Boolean true, the data type is bool, and this is a Boolean expression, but it is true. 3 plus 4 is equal to 7, so we have true on both sides, so that's most certainly true. Here we have a Boolean expression. 1 take away 1 equals 0. Well, that's true. But on this side, it's false. However, we only need one side to be true, and we do have that, so hashtag true. 2 is smaller than 0. Well, that's false, or true. So we've got one side which is true, and one side which is false. But because we've got one side which is true, that's enough. So overall, it's true. So we've now had true, true, true. Only in this case do we have one that's false. 3 equals 8. Well, that's not true. That's false. Or 3 is bigger than 4. That's false. So we have false on both sides. So overall, this OR statement is false. Notice that each OR statement that has at least one true component is true. But the final statement has 2 false components. So it is false. Instructions. Set the variables statement 1 and statement 2 equal to the results of the following Boolean expressions. So here's statement 1. 2 take away 1 is, which is 1, is bigger than 3, so that's false. Or minus 5 multiplied by 2, which is minus 10, is the same as minus 10. Well, that's true. So we have true and false, so overall it's true. 9 plus 5 is smaller than or equal to 15. Well, it is, because 9 plus 5 is 14. So that side is true. Or 7 is not equal to 4 plus 3. Well, that's false. But we've got one side that's true, so it's true. Run. Done. Oh, one more task. The registrar's office at Calvin Coolidge's Cool College has another request. They want to send out a mailer with information on the commencement ceremonies to students who have met at least one requirement for graduation, which is 120 credits and 2.0 GPA. So they want to send out a mailer with information on the ceremonies to students who have met at least one requirement. Not both, at least one. Write an if statement that checks if a student either has 120 or more credits or a GPA 2.0 or higher, and if so, prints, you have met at least one of the requirements. So we can go new line, if credits, so it's nice to be able to just refer to that variable. If credits is, we don't have to, whatever it is, if credits is greater than or equal to 120, or GPA is greater than or equal to 2.0, colon, now the function, we're just going to print something, then print you have met at least one of the requirements. Dot. And this is going to be a string. Done. Not also counts as a Boolean operator. The final Boolean operator we will cover is not. This operator is straightforward. When applied to any Boolean expression, it reverses the Boolean value. So if we have a true statement and apply a not operator, we get a false statement. So we could have not space true is equal to false. Not false is equal to true. Now, of course, true is not equal to false, so that overall is false. But if we not it, if we apply the not Boolean operator to it, it becomes true. And this is false, but if we apply not to it, it becomes true. Consider the following statement. Oranges are not a fruit. Here we took the true statement, oranges are a fruit, and added a not operator to make the false statement, oranges are not a fruit. This example in English is slightly different from the way it would appear in Python, because in Python we add the not operator to the very beginning of the statement. Let's take a look at, we don't say not oranges are a fruit, we say oranges are not a fruit, so we sneak the not in right into the sentence, but not in Python. So let's take a look at some Python examples. So if we do not in front of 1 plus 1 is equal to 2, it comes back as false. If we do not in front of 7 is smaller than 0, it comes back as true. 7 is smaller than 0. Well, we know that 7 plus 0 is 7 is smaller than 0 is false, but if we reverse it, it becomes true, so we get true. Instructions. Set the variables statement 1 and statement 2 equal to the results of the following Boolean expressions. So statement 1 is not 4 plus 5 is smaller than or equal to 9. Well, that's true, but if we not it, then it becomes false. Statement 2 says 8 multiplied by 2, which is 16, is not equal to 20 take away 4, which is 16. So 16 is not equal to 16, which is false, but if we reverse that, it becomes true. Okay, so 16 is not equal to 16. Well, that's false. It is equal to 16, but if we not it, it becomes true. Run. And now we've got a tick on task number 1. The registrar's office at Calvin Coolidge's Cool College has been so impressed with your work so far that they have another task for you. They want you to return to a previous if statement and add in several checks using and not statements. If a student's credits is not greater or equal to 120, but they notice that they can have just 120, but if it's not, it should print, you do not have enough credits to graduate. And if their GPA is not greater or equal to 2.0, it should print, your GPA is not high enough to graduate. And if their credits is not greater than or equal to 120 and their GPA is not greater than or equal to 2.0, it should print, you do not meet either requirement to graduate. Make sure your return value matches those strings exactly. Capitalization, punctuation, and spaces matter. So if your GPA is less than 2.0, we want to print your GPA is not high enough to graduate. Full stop. If credits is smaller than 120 and GPA is less than 2.0, we want to print you do not meet either requirement to graduate. And we missed one out. If credits is smaller than 120, we should print you do not have enough credits to graduate. Full stop. Did you add an if statement that checks that credits is not greater than or equal to 120? Effectively, I did. Because I said if credits is less than 120, we want to print that you do not have enough credits to graduate. I'm sorry, if credits is less than 120, then it is not equal to 120, and it is not greater than 120, because it's less than 120, so I have done that. If I click View Solution, oh, they want me to use not. Oh, there we go. So if not credits is greater than or equal to 120, but that's no different from saying if credits is less than 120, if it's not greater than or equal to. But I have to replace with that solution in order to get the tick. Yeah, so credits is smaller than 120 is generally clearer and more concise. Okay, let's move on. Else statements. As you can tell from your work with Calvin Coolidge's Cool College, once you start including lots of if statements in a function, the code becomes a little cluttered and clunky. Luckily, there are other tools we can use to build control flow. Else statements allow us to elegantly describe what we want our code to do when certain conditions are not met. Else statements always appear in conjunction with if statements. Consider our waking up example to see how this works. If weekday, print wake up at 6:30 p.m, else print sleep in. So if else. In this way, we can build if statements that execute different code if conditions are or are not met. This prevents us from needing to write if statements for each possible condition. Full stop. We can instead write a blanket else statement for all the times the condition is not met. Let's return to our if statement for our movie streaming platform. Previously, all it did was check if the user's age was over 13, and if so, print out a message. We can use an else statement to return a message in the event the user is too young to watch the movie. So if age is greater than or equal to 13, okay, they can be 13 now, print access granted, and then else : if And that's why we don't need else and then some sort of expression, because it's just a default. The point is it's the opposite of this being true. So else : print that. Instructions. Calvin Coolidge's Cool College has another request for you. They want you to add an additional check to a previous if statement. If a student is failing to meet one or both graduation requirements they want it to print, you do not meet the requirements to graduate. So if a student is failing to meet one or both, add an else statement to bring to the existing if statement. So we say if credits is greater than or equal to 120 and GPA is greater than or equal to 2.0, print you meet the requirements to graduate. Else : yeah, okay. So, of course, every other situation is accounted for now. Print: you do not meet the requirements to graduate, in speech marks. Cool. Else if statements. This is the final one we're going to do. We have if statements. We have else statements. We can also have elif statements. Now you may be asking yourself, what the heck is an elif statement? It's exactly what it sounds like. Else if. Yeah. An elif statement checks another condition after the previous if statement's conditions aren't met. We can use elif statements to control the order we want our program to check each of our conditional statements. First, the if statement is checked. Then each elif statement is checked from top to bottom. Then finally the else code is executed if none of the previous conditions have been met. Let's take a look at this in practice. The following if statement will display a thank you message after someone donates to a charity. There will be a curated message based on how much was donated. So if donation was greater than or equal to 1,000, print you've achieved platinum status. Else if donation was greater than or equal to 500, print you achieved gold donor status. And notice how that has to come later. It's not just arbitrary. Because 1,000, if someone donated £1,000 or whatever, that is greater than 500. So in a way, they should get gold donor status and silver donor status, But we're only coming down here if this has failed. Do you see? So if it's greater than 1,000, give them this message saying you've got platinum status. But what if it wasn't? What if it was £900? Okay, well then we can come down here, because it was greater than 500. So it's like we're filtering as we move down. And then what's left over? Well, what if it was 400 or 300? I still want to kind of distinguish the ones who gave more than £100 from those who gave less than 100. I want it to be a bit more granular. Okay, we'll say let's pick out, distinguish those who gave more than 100. And then we have just the leftovers, the people who gave under £100. So it's this kind of picking up, then picking out of the leftovers from that, picking out from the leftovers from that, and then finally a blanket rule. Let's take a second to think about this function. What would happen if all of the elif statements were simply if statements? If you donated $1,100, then the first three statements would all print because each if condition has been met. But because we used elif statements, it checks each condition sequentially and only prints one message. If I donate $600, the code first checks if that is over 1,000, which it's not, it's 600. Then it checks if it's over 500. Well, yeah, you do get that. But notice the sequence. First it checks, then it checks. so it prints the message. Okay, so it then checks if it's over 500, so it prints the message. Then, because all of the other statements are elif and else, none of them get checked, and no more messages get printed. Try your hand at some other elif statements. Instructions. Calvin Coolidge's Cool College has noticed that students prefer to get letter grades. Write an if, elif, else statement that if grade is 90 or higher, print A. Else if grade is 80 or higher, print B. Else if grade is 70 or higher, print C. Else if grade is 60 or higher, print D. Else print F. So grade is 86. If grade is greater than 90, is greater than or equal to 90, print A. Elif grade is greater than or equal to 80, print B. Elif grade is greater than or equal to 70, print C. Elif grade is greater than or equal to 60, print D. Else print, I think it's else colon, print F. I've got a feeling something's gone wrong here. Let's have a look. Oh, cool, done. So that's elif statements. Let's leave it there.